Today we're diving deep into two incredibly useful LINQ methods, ElementAt and ElementAtOrDefault. By the end of this video, you'll confidently choose the best method for your specific scenario. Let's get started. In the previous video, we touched upon the element methods, which are designed to retrieve a single element from a sequence. This sequence can take various forms: an array, a list, a data table, or any other data type. Such a sequence might be the data source we aim to query, or even the result of a previous LINQ query. For instance, imagine an array holding 5 numbers. If you wanted to grab the third number, you'd turn to an element method, which would then yield just that one number. So, in essence, element methods are designed to return a singular element from a sequence. Today, we're discussing the first two of these element methods, ElementAt and ElementAtOrDefault. Their primary role is to fetch the element at a specific index within a sequence. You'd typically provide an integer index, like 2, to get the desired element. Alternatively, you can also use an expression that results in an integer, such as 1 plus 2. Remember, indexing starts from 0. So, 0 refers to the first element, 1 to the second, and so forth. Let's put this into perspective with a practical example. Let's say we have a string array filled with various names. Our goal is to filter out and retrieve names starting with the letter M. Using a straightforward query, we can achieve this and end up with a sequence of type 𝗖𝗵𝗽𝗀𝗧𝗃, consisting solely of names starting with M. In many cases, we might want to convert this output to an array, and the toArray method comes in handy. However, there are times when we might only be interested in one specific element, perhaps the first one. This is where the ElementAt method shines. By using it instead of toArray, we extract just the first element, which in this case would be a string, because our sequence is of type 𝗖𝗵𝗽𝗀𝗧𝗃. Suppose I want to get the second element. Simple, adjust the index to 1, and we get our desired output. Now, imagine we want the fifth element. But wait! Our sequence only contains 3 elements. In such a scenario, the ElementAt method would throw an argument out of range exception. It emphasizes the importance of using an index smaller than the sequence's length. But what if we're unsure about the number of elements in our sequence and want to avoid potential errors? Enter ElementAtOrDefault. Using this method with the index number 4, for the fifth element, no exception gets raised. Instead, we receive an empty string. But why? This is the default value for the string type. Essentially, if the index isn't available, ElementAtOrDefault will return the type's default value. The default value of integer type is 0, the default value of Boolean is false, and so on. For each type there is a default value. That sums up the primary difference between ElementAt and ElementAtOrDefault. In summary, the ElementAt method retrieves the element at a specified index in a sequence. On the other hand, ElementAtOrDefault performs the same action, but returns a default value if the specified index is out of range. To put it another way, both methods will fetch the element at the given index if it exists. However, if the index is out of range, ElementAt will throw an exception, while ElementAtOrDefault will return the default value for the data type you're working with. It's important to note that these methods can only be used in this manner. This means, they operate based on the index of the element you wish to retrieve from the sequence. You can utilize both methods not only after a LINQ query, to obtain a specific element from the query result, but also within the LINQ query itself, in combination with other methods and clauses. This flexibility allows you to place these methods wherever they best suit your needs in the query pipeline. Now that we've laid the groundwork, let's put these methods to the test in some real-world scenarios. In our first example, let's consider a data table that has 2 columns, customer ID and quantity. This table lists various customers, some of whom appear multiple times. Each row represents an order made by a customer, and the quantity column indicates the total quantity of goods that the customer has ordered. Our goal here is to find out the largest quantity ordered for each unique customer ID. To achieve this, we aim to create a new data table that contains only those rows with the maximum quantities ordered for each customer. In this case, we should have these 3 rows as output. Now, let's dive into how we can accomplish this task using UiPath. Firstly, I've included a build data table activity, where I've defined the same table structure that I initially showed you. The resulting table will be stored in a variable named myTable. Next, I added an assign activity, where I wrote the LINQ query to achieve our task. In this query, I began by defining a range variable called row to represent the data source. I then used the group by clause to group all the rows belonging to each individual customer. Since I have 3 different customers, this will result in 3 distinct groups. Each group will contain rows specific to one customer. Following the grouping, I use the select clause along with the order by descending method to sort the rows within each group based on the quantity column. In other words, each group of rows will be sorted in descending order, so the first row of each group will hold the largest quantity ordered by that customer. At the end of this statement, I use the ElementAt method with the index 0 to fetch the first row from each sorted group. Remember, each group is a collection of data rows, so the ElementAt method will return the first data row from each group, essentially the rows with the maximum quantities for each customer. Lastly, I use the copy-to-data-table method to convert the output sequence into a data table. This completes our query. To display the new data, I've added a for each row activity, which will print out the content of our new data table variable. Let's go ahead and run the code to see the result. As you can see, the output gave us 3 rows, corresponding to the 3 unique customers in the table. For each customer, the row with the largest quantity was returned. Now, what if we want to retrieve the rows with the smallest quantity instead? Well, we can easily do that by tweaking the index used in the ElementAt method. Remember, we sorted the rows in each group in descending order, so the smallest quantity will be on the last row of each group. To fetch the last element, you can use the expression group.count-1. This gives us the last row in each group, and yes, the expression returns an integer, as the ElementAt method requires. Let's run the code and examine the results. As you can see, we again get 3 rows, but this time, these rows represent the smallest quantity for each customer. Alternatively, you could use the ElementAt method with the index 0 and simply change the sorting function from order by descending to order by. This will sort the quantities in ascending order, putting the smallest quantity at the top of each group. The result will be identical to what we achieved here. And there you have it. That's how you can use the ElementAt method in your LINQ query along with other clauses and methods to achieve specific tasks. I used ElementAt method in this example, but I can use ElementAtOrDefault instead, and the result will be exact the same. Let's explore another example. In this scenario, I've created a new variable of type DataRow. The objective is to retrieve just one row from the table and store the result in this new variable. To do this, I wrote another LINQ query. I start by iterating through all the rows of the table. Then, I apply a filter to keep only those rows where the customer ID is equal to 1. At this point, the LINQ query gives us a collection of rows that meet this criterion. After generating this filtered collection, I employed the ElementAt method with an index of 0 to retrieve the first row from the collection. In this context, the ElementAt method is used to filter the result of the LINQ query. To display the data of the row we've retrieved, I've added a write-line activity, which will output the content of the found row. Let's go ahead and run the code to see what we get. As you'll observe, the output will consist of just one row, specifically, the first row where the customer ID equals 1. And that's how you can effectively retrieve a single row from a data table using ElementAt method. I also used ElementAt method, but you can use ElementAtOrDefault and the result will be the same. Let's explore another example. In this scenario, I've created a new variable of type DataColumn. The objective is to retrieve just one column from the table and store the result in this new variable. To do this, I wrote another LINQ query. I start by iterating through all the columns of the table. Then, I apply a filter to keep only those columns which are of type string. At this point, the LINQ query gives us a collection of columns that meet this criterion. After generating this filtered collection, I employed the ElementAt method with an index of 0 to retrieve the first column from the collection. In this context, the ElementAt method is also used to filter the result of the LINQ query. I can also use ElementAtOrDefault to achieve the same result. Let's check the columns of the table. As you see, I have only 2 columns. The first one of type string and the second one of type integer. So, the result of the query should be the first column because it's of type string. To display the result, I've added a write-line activity, which will output the column name of the found column. Let's go ahead and run the code to see what we get. As you can see, I got customer ID as output, which is the column name of the string column. This is also how to retrieve a single column from a data table. Let's move on to another example, where we'll focus on retrieving the most recently modified Excel file from a specific folder. Or in other words, to retrieve the newest file from a folder. To demonstrate this, I have a folder filled with different Excel files, and I aim to locate the newest one, based on its last write time. So, I should get this file because it's the newest one inside this folder. To start, I've set up a variable to hold the path of the folder, from which we want to fetch the file. I've also created another variable of type 𝗘𝗵𝗽𝗀 to store the details of the file we find. In the next step, I crafted a LINQ query. The data source for this query is generated by a function that fetches all the files in the specified folder and casts the results to an array of type 𝗘𝗵𝗽𝗀. Following that, I used an order by clause to sort these files in descending order, based on their last write time. The query's output is a collection of 𝗘𝗵𝗽𝗀 objects, containing all the files in the folder, sorted by their modification date. After this query, I implemented the ElementAtOrDefault method, specifying an index of 0. This way, I'm fetching the first file from the sorted list, which should be the most recently modified file in the folder. It's worth noting that I used mixed syntax for the LINQ query. However, you can achieve the same result using method syntax as well. Here is an alternative version of the query in method syntax, which would yield identical results. To verify the outcome, I added a write-line activity to display the full path of the file we've identified. Let's run the code to see what happens. As you'll notice, the result is a single file, which matches the newest file in the folder. In our example, it's file number 8, just as I showed you at the beginning. And there you have it. That's how you find the newest file in a folder. If you want to locate the oldest file instead, simply modify the sorting order in the query from descending to ascending. Doing so will give you the oldest file in the folder. As you can see, we can use both methods in the same way to do different tasks. The examples were about different data types. An element must not be always a simple type such as number or string, but it could be any data type, such as DataRow, DataColumn, 𝗘𝗵𝗽𝗀, etc. ElementAt is good for when you're sure an element will be there at the specified index, while ElementAtOrDefault is safer to avoid errors. That's all about both methods.